Hello dear learners, in today's video we are going to talk about antitubercular drug, that is isoniazide. Full form is isoniazide and it can be abbreviated as INH. We are going to talk about the structural features including SAR of isoniazide. Now as you all know, INH is first line antitubercular synthetic derivative which is working on treatment of TB. Now INH, same as that of pyrazinamide, it is a prodrug. Prodrug which we have already discussed in our earlier video. Prodrug is nothing but it is an inactive form of drug which undergoes metabolism, and on metabolic reactions it get converted to active metabolite, that is here for INH it is isonicotinic acid. Now INH is a prodrug and active metabolite of INH is isonicotinic acid. Now we will discuss the structural features of INH. INH, as you can see in the structure, first this is the heterocyclic ring which is nothing but the pyridine ring. For these heterocyclic rings you can again go through our previous video lectures on the IUPAC nomenclature as well as numbering rules for the heterocyclic systems. And for the functional groups, now this is nothing but carbohydrazide. So for this common functional groups also, if CONH2, if you will see, this is amide. So for some common functional groups also you can go through our earlier videos for common functional groups. So links for both I have given it into the description box, so you can go through the earlier videos. Now INH, this is the pyridine ring, so this is pyridine heterocycle, right? Then coming towards the substituent, C double bond O is nothing but carbonyl group, C double bond O NH is nothing but amide, CONH2, then C double bond O NH, NH2 is known as carbohydrazide group. Here NH, NH2, only this NH, NH2 which is attached to carbon, it is hydrazine. But when C double bond O comes into picture, it becomes hydrazide. So this is C double bond O, NH2, NH2 is hydrazide. Now this N, if NH2, this CONH, NH2 है यहाँ पे, so this N, ये दो N है, this is first, this is second. So N, अगर N पे instead of H सब्स्टिट्यूएंट है एंड NH2 है, तो ये दोनों हाइड्रोजन के जगह पे अगर सब्स्टिट्यूएंट्स है तो दिस सब्स्टिट्यूएंट्स ऑन नाइट्रोजन, मतलब दिस इंस्टेड ऑफ दिस H and instead of this H2, if there are substituent presents, then they can lead to active or inactive compounds. Now it depends on the substituent whether it is present at first nitrogen, second nitrogen, or it is monosubstituted, disubstituted on that. Now if this NH2 के जो substituent है, if R1, R2, for example, there are two substituents, and if this is isopropyl, then it forms iproniazide, and iproniazide is having a psychomotor stimulant activity. So this way we can present the, we can substitute the substituent also. Okay, we can change the substituents, but INH is the active drug which is a prodrug, gets converted to the active form isonicotinic acid, which is acting as antitubercular drug by the mechanism that it is responsible for inhibition of mycolic acid synthesis in the bacteria. So IUPAC nomenclature, if you will see, this is pyridine 4 carbohydrazide. That means pyridine रिंग के 4th पोजीशन पे फंक्शनल ग्रुप है carbohydrazide. So this is numbering, as you can see, anti-clockwise direction. This is first, second, third, fourth. Even if you are numbering from here, 1, 2, 3, 4. So 1, 2, 3, 4. This is 4th position. At 4th position, carbohydrazide group is there of pyridine ring. So it is pyridine 4 carbohydrazide. Now this nitrogen, first nitrogen, many derivatives are possible, but this parent compound is more potent compared to the derivatives. This carbohydrazide group which is present in the structure. So in the exam, many type of questions can be asked in the INH on the INH. So the first is first type of question which can be asked is name the drug which contains carbohydrazide group, or they may ask you name the drug which contains carbohydrazide group along with the pyridine heterocycle, or they may simply ask you draw the structure of drug containing pyridine heterocycle. They may ask you only abbreviated form, that is INH, or they may ask you isoniazide, or they may ask you draw the structure of any first line antitubercular drug. So this is the very famous first line treatment for the treatment of tuberculosis. This is INH. So according to the SAR, INH, many derivatives are possible if there are substituents present, but the potent derivative is isoniazide. The potent compound is isoniazide, which is a parent compound. The pyridine heterocycle which is present in the INH, this can be replaced with some other heterocycle, but it leads to decrease in antitubercular activity. It may provide some other activity, but pyridine ring, if it is there, then it is responsible for antitubercular activity. Isonicotinic acid, which is active metabolite of INH, the structure I have shown it here. Same structure is there. Instead of carbohydrazide, this NH2 is getting replaced by NH2 by hydroxy, same as that of we have seen in pyrazinamide. Amide was getting replaced by acid, that is carboxylic acid. So here also amine is getting replaced with the hydroxy. So it is COOH now. So it is isonicotinic acid. Now these substituents we have already seen on the hydrazide group, NH2. So this is if NH पे alkyl group है, alkyl group is getting substituted, then they may lead to various derivatives which can be active or inactive present depending on the substituent. So with this we finish with the structural features and SAR of INH.